because I know you guys just can't get enough, we're going to do a few more u substitution examples. So here we have the integral that we're going to evaluate, dx over x times the natural log of x in the denominator. So rearranging using our algebra skills is always something that's really important. And so what I want to recognize, this is the same as 1 over x times 1 over ln x times dx. So we need to determine how to choose u. We've got lots of choices. I could just choose 1 over x, or I could maybe choose the natural log of x. I said lots of choices. I think there are 2 choices here. I'm going to choose that expression in the denominator. I'm going to say, let u equal the natural log of x. And the reason I'm choosing it that way is because that I know the derivative of u with respect to x will be 1 over x. And of course, I see the derivative in the problem. So du equals 1 over x dx. Got all of that. So this integral would turn into 1 over u, and 1 over x dx is simply equal to du. So this integral becomes the natural log of the absolute value of u plus c. And we have to say, well, what is my u value here? That would be the natural log of u. U we said was ln x. So the natural log of the natural log of x plus c. And again, we can always check, especially if we're not sure, by taking the derivative. So the derivative of what's in the box should give me the integrand that I started with. All right, let's do some more. So here we have another integral. X times x minus 1 to the 10th dx. So in this situation, I'm going to choose my u value by using what was in the parentheses, x minus 1. I'm going to say let u equal x minus 1. Well, that means that the derivative of u with respect to x, the derivative of x is just 1, and the derivative of 1 is 0, so we have a 1 there. So that means that du equals dx. So if I go to create this substitution, I have x times u to the 10th, and dx is equal to du. Well, how am I going to deal with this? I still have an x in here. One thing that I can do would be I will rearrange u and say that u plus 1 equals x. So I can sub in for x here u plus 1. And that gives me u plus 1. And I still have u to the 10th du. At this point, it doesn't look awfully different than what we started with. However, if we look at this original expression and we tried to FOIL that out, that would just be monstrous. X minus 1 times x minus 1 times x minus 1 times x minus 1. Do that 10 times. That would be big. But with what I have here, that u to the 10th, I can distribute that. So this is the same as u to the 11th plus u to the 10th. And that is easy to integrate using my power rule. That would be u to the 12th over 12 plus u to the 11th over 11 plus c. And at this point, all we have to do is plug our u value back in. Remember, u is equal to x minus 1. So I have x minus 1 to the 12th over 12 plus x minus 1 to the 11th over 11 plus c. And that would be my final answer for this problem.